this year, and I found it very interesting, and maybe you could have thoughts to help me figure out what happened. So this was a 50-year-old woman who presented with a 2-centimeter breast mass. She was biopsied at an outside institution, and her pathology report read poorly differentiated, infiltrating ductal carcinoma, ER/PR positive, and HER2 equivocal. She then was found to have an axillary lymph node, and that was biopsied as well, and the biomarkers repeated on the metastatic carcinoma. However, this time HER2 came back 3+. So the primary tumor was 2+, and the metastatic tumor 3+. And then when the slides came to us, we only had the primary tumor, and it tested HER2+. And this is a histologic picture of the tumor. As you can see, sheets of malignant cells with no specific differentiation invading into the stroma. So it's a high-grade tumor. And you can see here more of the nuclear pleomorphism and mitotic activity. And so we repeated the stains, as I said, on the primary tumor. And interestingly, this is ER. ER had sort of a heterogeneous distribution. Like here's another example where areas of the tumor were completely negative or weakly negative, and other areas looked very positive. And her HER2, when we repeated it, the outside hospital reported it as 3+. But when we repeated it, it showed only this kind of staining, which was 2+. And so we did the FISH, and so initially this is the first FISH we did. We see equal numbers of HER2 gene copies and CEP17. And this is the report. The ratio was 1.2. So by immuno was equivocal. Now the FISH says it's negative. So this case was all over the place. First, it tested a IHC3 positive. And then when we got it, it's 2+ by immunohistochemistry. And when we did the FISH, it came back negative. And also the pattern of the ER expression was very weird, like areas with the positivity and the negativity. So I suspected I couldn't just sign out the report. I felt like there's something weird about this case. So typically FISH, we count 20 cells. So since I suspected heterogeneity, I asked the lab to count 80 cells instead. So when the lab counted 80 cells, they found pockets of cells with increased HER2 copy gene. And in these pockets, the HER2 was amplified. And, but however, the cells were not enough, the number of the cells was not enough to raise the ratio. Oh, sorry, this is the first. This is the second one that they found the pockets with gene HER2 copy over amplification. And if you look at the second FISH, you see the average HER2 copy number 4.6, the average chromosome 17, 3.3, and the ratio 1.4. So instead of negative, it became equivocal because of the increase in the copy number. And if you remember from my lecture yesterday, for polysomy 17, the cutoff is 3 or more copies. So as you can see, when we increase the cell count, the average chromosome 17 number was, CEP was 3.3. So this is an example of a case with polysomy 17. Again, you probably attended my lecture yesterday, so just as a reminder, it's polysomy 17 is defined as the presence of extra copies of chromosome 17 with more commonly focal pericentromeric gains in CEP17, and the cutoff is 3. And here is again as a reminder, there are different types of polysomy 17. You can see here pericentromeric gains, actual increase in the whole chromosome, or co-amplification of CEP and HER2. So I'm just presenting this case because of the very unusual presentation of the immunohistochemistry and the repeat immunohistochemistry and the difference between the primary profile, biomarker profile, and the metastatic biomarker profile, and that's why you have to have a sort of low threshold to increase the number of cells counted by FISH in cases where you're suspecting heterogeneity or polysomy 17. And that's it, I think. I already presented this yesterday, so you're already familiar with all this. That's it.